Imagine building a system that helps a car understand the road just like a human driver does. And that's exactly what this project is about. You're creating a computer vision model that reads lane markings in real time, so autonomous vehicles can stay centered and make safe decisions on highways and city roads. This matters because lane detection is one of the core building blocks of autonomous driving and modern driver assistance systems. The global market for this technology is exploding, and companies need people who understand how to turn raw camera footage into reliable road awareness. You'll see this tech inside lane departure warnings, steering assistance, autopilot features, calibration tools, and even road mapping systems used for infrastructure planning. These features are becoming standard in new vehicles, which means the demand for engineers who can build them is rising fast. The industry's hiring range from autonomous car companies to traditional automakers, ADAS providers, simulation firms, and testing labs. If you're aiming for future-ready computer vision roles, this project is one of the most direct paths in. To build a solid lane detection system, you need a mix of computer vision fundamentals and deep learning techniques. And the good news is that most of these skills are already familiar to students with basic CV experience. You'll work with classic image filtering, edge detection, and segmentation because these steps help the model understand lane boundaries under different lighting and weather conditions. Tools like OpenCV, PyTorch, TensorFlow, and UNet architectures allow you to move from simple line detection to pixel-level lane prediction. Numerical libraries like NumPy and visualization tools like MATLAB Bin help you inspect results clearly, while simulators such as Carla or AirSim give you a safe space to test driving scenarios without using a real car. Soft skills also play a big role. You need systematic problem solving, attention to tricky road edge cases, an understanding of safety-critical thinking, and a mindset focused on performance optimization. Recruiters love these skills because they show you can build reliable systems that hold up in unpredictable environments on real roads. The journey starts with mounting a front-facing camera or setting up a simulator, then performing calibration so the video feed accurately represents the road. Once the camera pipeline is ready, you apply pre-processing steps like perspective transformation, grayscale conversion, Gaussian blur, and thresholding to isolate lane markings more clearly. You can begin with a traditional computer vision approach using canny edge detection and health transform to find lines and curves. This helps you understand the problem deeply before moving to more advanced deep learning methods. For a stronger model, you train UNet or SegNet on datasets such as TwoSimple or BDD100K, labeling pixels as lane or background. These models learn to detect lanes, even when markings are faded. After training, you integrate lane departure warnings and test across diverse lighting conditions, rain, and shadows. The goal is smooth, real-time performance above 30 frames per second. Finally, you deploy on embedded hardware. Beginners usually need 7 to 10 weeks, while those with prior CV experience can complete it in 4 to 6 weeks. Mastering lane detection places you directly in the talent pipeline for companies building the future of mobility. You become a strong candidate for roles in autonomous driving engineering, automotive computer vision, ADAS software development, perception engineering, robotics, and automotive AI research. Recruiters expect you to understand real-time processing, safety standards, and how to handle difficult road situations, such as poor lighting or worn-out lane markings. They look for resume keywords like lane detection, segmentation, OpenCV, UNet, and automotive AI, because these terms signal hands-on capability. Hiring companies include Tesla, Waymo, Cruise, Argo AI, major automakers like BMW and Mercedes, plus top Tier 1 suppliers and hardware companies like Mobileye and NVIDIA. Salary ranges are strong, with India offering 9 to 18 lakhs for entry roles, and global salaries often crossing $100,000 at the start. Mid-level roles go even higher, especially in high-tech autonomous teams. This project can become a standout portfolio piece if you build it properly. Start building this today and put it on GitHub,